Good morning, everyone. Well, let's get started. We are going to cover limits at infinity. So that is kind of weird that we are spending all this time on derivatives and now we're going back to the topic of infinity. Well, it's because in our discussion about graphing and how graphs and derivatives and everything are related, when we actually get to drawing the graph of a function, we need a little bit more information than what the derivative alone can tell us. And we need to look at the end behavior of the curve, and a limit is going to actually allow us to do that because we can let x go off to either infinity or negative infinity. So your end behavior, it can vary greatly from function to function. So polynomials, they have their end behaviors, their ends go off to positive infinity and negative infinity, and other functions approach a particular value, or in other words, they have a horizontal asymptote. So they approach some other y value. So let's look at this function, 4x squared over x squared plus 4. So I already went through the derivative on my own and just put out where the function was decreasing, where it was increasing, where it was concave down, and concave up. So it's got two places where concavity is going to switch, and because it went from decreasing to increasing, it's got a relative minimum. So we can draw two slightly different graphs. We can draw something that kind of goes like this, where the ends don't really flatten out, and I drew it so well, but they kind of do keep going up and up like a logarithm or a square root graph, or we could draw something that doesn't go up forever, that actually approaches some sorts of horizontal asymptote. So something like this. And so we're just off of this information alone, we don't know which one of these two we could possibly have because they both work. So how do you know which one is correct? Well, that's why we need to look at what the ends are going to do as x goes off to positive infinity or as x goes off to negative infinity, which means we are using a limit. So this example here, the limit as x approaches infinity of 1 over x to the fourth, it's asking about the end behavior of the function as x gets larger and larger and larger and larger as it goes off to infinity. So if this limit exists, so if it actually equals a number, that's the horizontal asymptote that the function is going to approach. And if the limit doesn't equal a value, like it goes off to infinity or negative infinity, then the function is just going to go up forever or it's going to go down forever. So this one in particular, 1 over x to the fourth, that is going to equal 0. Thus, it has a horizontal asymptote right at 0. So that's a little intro for this. In the next video, we'll go over how to actually know what these limits are going to do, how to evaluate them, but there you go.